I mean, seriously?
These changes in technology can inspire complete changes in industry.
Okay, good afternoon, everybody. Thanks very much for asking me to come along and talk to you today. Actually, this story is going to end with Alan Turing rather than start with him, but he's a sort of key player in all of this as far as the UK goes. So how come doing your maths homework and liking problem solving, wanting to do something different, thinking about maths as a creative activity, not a handle turning or efficiency, something that you secretly enjoy doing, it's your hobby. How come all of that means that we get to monkey around with companies like this, work in some of the most exciting sectors in developed economies and all over the world? And really it's about data. And this has seen a revolution in the way in which mathematics is used and abused by many public sector and corporate organizations the world over. Data, big data, let's get rid of the hype about big data. What I want to talk to you today is about some of the things we actually do with data sources. So where does the data come from? Well, it can come from a number of places. So 24/7 social media, our tweets, our emails, 24/7 telephone calls, our mobile phones, collecting all that data, our texts. It can come from online blogging sites. Anything that we do on digital platforms is captured. Oh yeah, so that's sort of online transactions, isn't it? So Bet in Play, Tesco.com, buying our holidays, Amazon. If you think about it, the convergence of digital platforms and the fact that we now want, and we just expect everything everywhere. It's kind of human right, really. We just expect stuff to turn on and be there. And actually it's mildly irritating, isn't it, when we come to a splendid place and there's no Wi-Fi. We want everything, everywhere. And we also want it kind of 24/7. So the data is pervasive. And of course, there's a generational attitude to that too, because, you know, no one under the age of 25 thinks that Facebook is evil. You know, if you say, well, is it okay for Facebook to make money off your data? Well, actually, it's free to me. You can't beat free. There was a day before there was an internet and before there were mobile phones when people still went dating. They still met one another. They still made arrangements. Okay, but we didn't have our mobile phones, we didn't have everything everywhere. Now we do, and so there's a kind of exchange between benefits that the individual receives and benefits which the corporation can receive. And actually, I'd really like Twitter and Google and Facebook to make even more money, invent more cool stuff, and give it to me for free. That's a generational kind of issue. Insights. What we really want are insights. No point in turning a kilogram of data into a kilogram of matrices or a kilogram of PowerPoint. Actually, the sorts of people I want to work with, they'll take kilograms of data arriving 24/7. So think of looking at the financial markets across the world, all the data changing every moment, arriving all the time. If I can't analyze it in real time, if I can't create insights in real time, then I can forget it. So that's very different from bioinformatics, say, where if you get the proteome of a certain organism, you've literally got a month of Sundays to sort that out. You can just as long as you like, as long as you do it right. But actually, for some of these customer-facing areas, you've really got to get on with it and to be ready to say, what evidence have we seen? What does that tell us about what's going underneath? What's the opportunity? So companies are alive to this, and indeed the government's alive to this too, as to why this is so important to make our companies, particularly in areas where they're facing customers, we call that business to customer, B2C, to make them more competitive, to introduce new products and services, and increasingly the innovation, when they want innovation, they look to their group of mathematical scientists. Now, in universities, we're called mathematical sciences, so we work in things like mathematics departments. But in business, actually, we don't really get called that. We'll be called the customer insight team or the business insight team or something like that. But actually, increasingly, these people recognize each other and they recognize the value in each other. And it's kind of creating a new profession or a new discipline, the discipline of data science. And if you like, that goes from soup to nuts. It goes from very upstream stuff, I'll talk about some of that in a moment, to some very downstream things of making products and services, which is engineering efficiencies, creating apps, creating access, and things like that. So insight is what we want. And actually, we don't just want insight, we want actionable insight. So it's no good showing people just cool stuff if they can't make a decision and therefore invest something, stop themselves invest something, de-risk an investment or something like that. So actually, we want actionable insights. So analytics. So what is analytics? Well, analytics is the term for applying mathematical sciences to the data and bringing out these insights. And it's increasingly a term that we're prepared to use in academia, although academia has been relatively slow to kick on to this, and a lot of the early work was done by industry. So what sort of mathematics would we need to know about if we wanted to do analytics and work for glamorous companies in customer-facing sectors all over the world? Well, it's a real mix. So quite a lot of work is done with modern network theory and graph theory. So networks, just nodes and edges. And sometimes in my life, that has to model people communicating one another. So the peoples are nodes, and the edges are spontaneous conversations. So time's arrow matters. Think of the edges as twinkling like stars, appearing and disappearing the whole time. And we want to follow information and rumors through these things. Sometimes the people themselves are changing as a result of being influenced. That's a kind of diffusion process. And sometimes the fact that they know something, like my mum, if she knows something, she calls everybody. That's a fully coupled system. The state I'm in affects my communication, and the amount of communication I'm having affects the state I'm in. And so it's quite possible to have situations where there's big conversations going on about topics, and we can see these online, and it'll never get to a steady state. Because if everybody kind of agreed, the Turing mechanism we heard about early on kicks in and forces some disagreement, and then there's a period of what we could euphemistically call separated development between communities before they come back and agree again. Topology, the shape of data. Who would have thought that now we would want to look at the shape of large data clouds, the shape of large networks, and that requires us to know something of topology. And modern topology, computational topology, is bringing in new methods which are a bit like the Fourier transform. So instead of splitting signals into frequencies, we now split shapes into smaller shapes which persist in some sense, and so we believe they're stable to the data as opposed to little shapes that appear and disappear and are unstable things in the data. Obviously, there's a large amount of linear algebra going on because we're going to have arrays, complete or otherwise. Sometimes these are n-dimensional arrays called tensors, and we need to split these up and join them and merge them and do things like probability. So Reverend Thomas Bayes should feature in all our lives. A man called James wrote a great book, life-changing book, called Probability, the Logic of Science. And it's the logic of everything, actually. It's the best way to think about probability. And we need probability because we need to make inferences. We need to say something about ethics. There's a creepy line If companies or governments start to watch you too much, you do feel uncomfortable. And maybe they cross that creepy line. But as I've already said, part of that is generational, part of that is pragmatic, part of that is, well, weighing the benefits versus the loss. And that's a real huge issue. So in all of our projects, we need some ethics these days. And it's a bit like salt in a meal. You need some, but you don't want it all over the plate. When we think about applications, we're now thinking about more modern applications, novel applications. So you saw some pictures of cities up there. We're doing a lot of work comparing the social networks of different UK cities to try and decide if things that are successful in Bristol, if we transpose them to Newcastle, would they work just as well? Or things that work in Newcastle, would they work just as well in Bristol or something? You know, is learning transposable between cities, or are there social constraints and social networks, which means it would never work here? And so we're having to do work like that. I've also started companies that do behavior-based credit scoring for people by their mobile phone data in third world countries. Give me 2 weeks worth of your data, see your incoming, outgoing texts and calls and stuff like that, and we can credit score you better than Fair Isaacs, better than Experian, better than Equifax. And of course, these people can't be banked because there's no banking infrastructure. There's a double leapfrog going on in such situations where people are going to bank through the phone, and now they can get credit through their phone. So lastly, I want to talk about aspirations, and this brings us back to Alan Turing. And the government's woken up to this. There's going to be something national called the Alan Turing Centre, and it's a centre for data science. And it's mathematical sciences front and centre. So those of us who are in there trying to shape it are making sure that with mathematical sciences are front and centre. And that's because, broadly speaking, the UK is very good at mathematical sciences, and we have a bed of excellence. What we need are people to come through and be trained and take part in these industries. And of course, the government's interested for obvious reasons. Industry is very well interested because not only do they want the applications immediately, and they will race to put these things into use. You saw all the brand names put up there on my Bloom movie. So Bloom's the company I work with, but you know, when we go out to companies, they all get it. They don't pause to think, well, have you got the right number of scientists on here? They need to run with it. So what we're doing there is we're really saying, this train hasn't left the station yet. We're seeing these massive digital resources emerge. Sometimes we have access to them because they're open. Sometimes we have to work, they're proprietary, so we have to work with the data owners. And that's fine, that's cool. We can find a way to do that. We need people. The train hasn't left the station. There are ideas that people like myself and some of the great people I've worked with have had and put into action. You've seen some of these there, and to trying to target information better so we don't irritate you. We've got a project at the moment where we're looking at potential multi-point terrorist attacks in urban environments and how we could target the right information to the right people. Some people can go home, some people need to run and hide. But equally, we're crowdsourcing intelligence at the same time. There are all sorts of applications here where there's a sort of beneficial balance, and sometimes that's difficult to strike. Nevertheless, my appeal to everybody is do your maths homework. If you want to be involved in this, then get on a course where data science is a mainstream part of applied mathematics. You will vote with your feet because the companies that have data, that own proprietary data or have access to open data, really are very, very keen to outrun their competitors, not just in the UK, but in the US, in Asia, across the entire world. So we in the UK need our brightest and very, very best people to come and do this, come and work in these fantastic areas and have really, really enjoyable careers. Thank you very much, everybody.